Alright, in the last video we looked at finding the inverse of a 2x2 matrix. We're now going to look generally how to find the inverse of a matrix and then use the example of a 3x3 to see how this works. So, step 1, you have a matrix, you find the matrix of minors, and this is just a brief intro. We will, when we run through the example, explain what all these things mean. And then next up we find the matrix of cofactors. Then we find the adjugate matrix. And then we divide by the determinant, and that's dividing by the determinant of the original matrix. Okay, so we're going to cut that off. And now we're going to take an example of a matrix A, where A is equal to 7, 2, 1, 0, 3, minus 1, minus 3, 4, minus 2. And the first step is to find the matrix of minors, and I'm going to call that min of A. And what we do is we take, so we say we want to find this top left element. We take the top left one here, cross out this row and this column and this row, so you cross out the row and column that your element is in, and then you find the determinant of what's left over. So for this top left column we find the determinant of 3, minus 1, 4 and minus 2, which is 3 times minus 2 minus 4 times minus 1, which comes out as minus 2. You have to be able to do these in your head, because if you write them all down for a 3x3 matrix, it just takes forever and ever. So if you can't do that in your head, I would have some more practice at that before you watch the rest of this video. But I'm just going to fill these in. The next one comes out as minus 3, 9, minus 8, minus 11, 34, minus 5, minus 7 and 21. So the next part, part 2, let's say, let's call this part 1, is the matrix of cofactors. And what do we mean by this? Well, basically we have this pattern with a 3x3 matrix. It looks like this. And this is just the rule that we have to follow. So even if you're working with 4 dimensions, 5 dimensions, you just start with a plus and you go minus, plus, minus, plus, and you just keep going like that, okay? And what this means is, where there's a plus, we keep that element with the sign it currently is, and where there's a negative, we change the sign of that element. So this leads us on to the cofactor matrix of A. And we're dealing with the minor matrix, by the way. So plus and minus 2 stays the same. The 3 changes sign. The 9 stays the same. The minus 8 changes sign. The minus 11 stays the same. The 34 changes sign. The minus 5 stays the same. 7 changes sign, and 21 remains the same. Now step 3 is the adjugate matrix. We'll just call this adj of A, and an adjugate matrix is when you transpose the matrix. The adjugate matrix is the matrix of cofactors transposed. So from here we transpose the matrix, but what we mean by transpose, we just mean we swap the rows and columns over. So this is column 1, and this becomes row 1. So that's minus 2. Oh, sorry, this is row 1, this becomes column 1. Minus 2, 3, 9. Row 2 becomes column 2. 8, minus 11, minus 34, and row 3 becomes column 3. So that's minus 5, 7, and 21. Notice all the diagonal elements stay where they are. Everything else sort of flips over. The final steps are defined by the determinant, and that's the determinant of the original matrix. So we will be doing a full video on determinants, but what you have to do is go according to this pattern. So you choose a row or a column, any row or column, but I'm going to choose this one because it's got a 0 in, and you look at this pattern here, and you take these numbers and then you multiply them by their minor matrix and the determinant of their minor matrix. Alright, so that might sound a little bit complicated, but you'll see. So we'll do 7 times by the determinant of 3 minus 1, 4 minus 2, and these little lines here just mean the determinant of this. Alright, and then we've got the minus sign here, so it's minus 0. It doesn't matter what this is because that's 0, so it's just going to turn out 0 anyway, but it would be 2 minus 2, 2, 1, 4 minus 2 is that little matrix. Alright, and then we're doing plus minus 3, so that's minus 3, and this one is 2, 1, 3, minus 1, and we've worked out these minus from earlier, so we can just look at where they are. So it's minus 2 and 5, so we're doing 7 times minus 2 minus 3 times minus 5, and that's equal to 1. So our determinant of our matrix is 1. So that means that A inverse is equal to adj of A, which is minus 2, 8, minus 5, 3, minus 11, 7, 9, minus 34, and 21. Which can be quite long and quite tricky to remember because there's a lot of steps, but once you get the end of it, none of the steps are too complicated. It just becomes running through the same thing every time. So we'll do some more examples and